Fusion Mobile, quality e-learning experience on the go.
Okay, my loved one, today we are taking on models of atom and nuclear physics. I would really like you to visit the models of all these great men. J.J. Thomson, the model of Rutherford, Bohr's model of atom, electron cloud model, and if possible, you can move ahead and study something like liquid drop model, so that we discuss it through my website. If you can carry a research on that side, I personally will guide you. But today, let's move on with what we are doing. Nuclide. A nuclide of an element with the same proton number Z but different nucleon number A or neutron number N are called isotopes of that element. And the process of actualizing this is known as isotopy. Use of radioactive isotopes. It can be used in technology, it can be used in medical, even in agri, even in downstream and upstream of oil companies and industries today. We can use radiation everywhere and radioactive isotopes everywhere. So let's discuss radioactivity. Radioactivity. Okay. Radioactivity is the spontaneous decay or disintegration of unstable nuclei of the atom of an element by the emission of alpha particles, beta particles, and gamma radiation with the production of energy. What do we mean by that? If I have this, for example, to be a block, and inside here is a radioactive element, that a day will come, this particular element will disintegrate, and that day is called the half-life of the element. And when it disintegrates, it will give out three major things. One, the alpha particle, alpha. Two, the gamma particle, highly deflected. This is beta particle. Then the final one, which will be undeflected, is the gamma particle. This one will have a slight deflection because it's heavy. This one will have a very high deflection because it's light and at the same time negatively charged. So it will fly or move over to the positive terminal, while this one, positively charged, will move to the negative terminal, while gamma, without a charge, cannot be altered or deflected in an electromagnetic field. Nuclear fission is a decay process in which an unstable nucleus splits into two parts of comparable mass. Nuclear fusion is the joining of two or more light nuclei to form together in a heavy nucleus with the release of enormous energy. Fission, you have one big element and it splits into two of comparable masses, while nuclear fusion, this one here is for fission, while for fusion, now you have two light nuclei and they come together to form one large nuclei. This one is coming together to form this. This one is for fusion. Then before we go into energy quantization, my dear, I would like you to take a critical look of half-life of an element. Half-life T is equal to N2 all over decay constant, where N2 is 0.692. So we'll say that T is equal to 0.692 all over decay constant. Pick up your past question and see how many questions you can solve when we talk about radioactivity and nuclear fusion. If you encounter any problem, visit Sayidi Jesus I mean my very self, in www.wunderbaik.com, or log in to Physics Clinic again of Fusion Mobile, because as the days goes by, more lectures are rolling in. We'll take you to the next lecture, which is quantization, energy quantization, and I know you will enjoy that particular lecture.